Scientists have intercepted a mind-blowing mystery, a repeating signal from a source 3 billion light-years away. Dubbed Fast Radio Burst 121102, this signal defies explanation with its staggering power and persistence. Could this be the first sign of an advanced civilization beyond our imagination? This signal's home isn't some cozy star neighborhood. It's in a galaxy far, far away, in a spot with an insane magnetic field. The prime suspect? A magnetar. Think of a neutron star, but way more extreme. A super-dense object with a magnetic field so strong it could mess up your credit card from thousands of miles away, if you were anywhere near it, which you're not, thankfully. And yet, amidst the chaotic forces that twist space itself, something far stranger stirs beyond the veil, a force no one has ever truly understood. Now, fast radio bursts have always been a head-scratcher for scientists. Most of them are one-hit wonders. They blast out once and that's it. But Fast Radio Burst 121102 broke that rule. It forced everyone to rethink what they thought they knew about these bursts. Maybe they aren't all from dying stars or cataclysmic events. Maybe, just maybe, something else, something continuous, is powering them. Let's rewind to 2012. That's when this repeating burst was first caught by telescopes. Back then, fast radio bursts were still a fresh mystery, having only been discovered 5 years earlier. Astronomers didn't expect any of them to repeat. When this one did, it was like finding out your favorite fireworks show had an encore you weren't ready for. Here's where things get spicy. This signal's strength and the extreme environment it comes from hint at something wild happening. The magnetic field around it is off the charts. It's so intense that scientists think it might be near a supermassive black hole or deep inside some chaotic star-forming region. To put it bluntly, this isn't just some random noise from the universe. Something's going on out there, something powerful enough to send signals across billions of light years. And because Fast Radio Burst 121102 keeps repeating, it's giving scientists plenty of chances to study it. Every burst is like a clue in a cosmic scavenger hunt. Over the years, astronomers have thrown every tool they've got at this thing. Giant radio telescopes, deep space observation arrays, you name it. They've tracked the bursts, measured their strength, and tried to figure out exactly where they're coming from. And while they've learned a lot, they're still scratching their heads over the source. Some researchers think it could be a young magnetar surrounded by a dense cloud of particles. Others suggest it might have something to do with a neutron star orbiting a black hole. Either way, the environment around Fast Radio Burst 121102 is nothing short of extreme. The bursts themselves are super brief. We're talking milliseconds. Yet in that tiny fraction of a second, they release as much energy as our sun does in an entire day. That's some serious power, and they're not coming in at regular intervals either. Sometimes there's a flurry of them, and then it goes quiet for a while before picking up again. In 2017, a huge breakthrough happened. Scientists pinpointed the exact galaxy this repeater was coming from. It's a small dwarf galaxy, not exactly the kind of place you'd expect to find something so powerful. But then again, the universe loves throwing curveballs. This little galaxy, with its strong magnetic fields and turbulent environment, turned out to be the perfect home for such a bizarre phenomenon. To really understand what's going on, scientists need more data. They're watching this repeater like hawks, waiting for each new burst. Every time it repeats, they gather more clues about the magnetic field it travels through, the space it's coming from, and what might be causing it. And here's the kicker. Fast Radio Burst 121102 isn't alone anymore. Since it was first discovered, a few more repeating fast radio bursts have been found. Each one adds a new piece to the puzzle, but none of them are exactly the same. Some repeat more often, some are stronger, some come from entirely different kinds of galaxies. What's clear is that fast radio bursts aren't a one-size-fits-all phenomenon. There might be different kinds of events causing them, From colliding stars to exotic objects we haven't even imagined yet. Just when they thought they had answers, new signals brought more questions, pushing them further. In the meantime, fast radio burst 121102 remains one of the most closely watched objects in the universe. It's like a cosmic lighthouse flashing its mysterious signal across the vast darkness of space. Scientists will keep following its light, hoping it will lead them to answers about what's really going on out there. Fast radio bursts are a real puzzle for science. They don't fit neatly into any existing categories. One of the biggest questions is what powers them. Whatever it is, it needs to be something capable of releasing enormous energy in an incredibly short period of time. Think of it like a firework, but on a cosmic scale. And instead of colorful explosions, you get powerful radio waves that can be detected billions of light years away. Unlike visible light, radio waves can travel through space without being blocked by dust and gas. This means astronomers can pick up these signals from much further away than they could see with ordinary telescopes. But it also makes it harder to figure out exactly where the signal came from. It's like trying to find the origin of a single ripple in an ocean. The first fast radio burst ever detected was found in 2007. At first, scientists thought it might have been a fluke, some kind of interference from Earth or a glitch in their equipment. But as more bursts were detected, it became clear they were a real cosmic phenomenon. The discovery of fast radio burst 121102 as a repeater was a game changer. It showed that not all fast radio bursts are random one-time events. Some of them, like this one, seem to be tied to a specific source that can produce multiple bursts over time. Astronomers have spent years trying to figure out what could cause such bursts. One theory involves neutron stars. These are incredibly dense objects formed when massive stars run out of fuel and collapse under their own gravity. A neutron star is so dense that a sugar cube-sized amount of its material would weigh as much as a mountain on Earth. If a neutron star has an extremely strong magnetic field, it can become what's known as a magnetar. Magnetars are known to produce bursts of high-energy radiation, and some scientists think they could be responsible for at least some fast radio bursts. Another theory involves black holes. In particular, some researchers think fast radio bursts might be caused by interactions between neutron stars and black holes. Imagine a neutron star orbiting a black hole. If the neutron star gets too close, the intense gravitational forces from the black hole could cause it to emit bursts of energy. Over time, as the neutron star spirals closer and closer to the black hole, the bursts might become more frequent or more intense. One thing that makes fast radio burst 121102 so interesting is its location. It's coming from a dwarf galaxy, a small, faint galaxy with only a fraction of the stars found in a larger galaxy like the Milky Way. Dwarf galaxies are often home to regions of intense star formation. This means they're full of young, massive stars that burn brightly and die quickly, often in spectacular supernovae. The remnants of these massive stars, neutron stars and black holes, could be responsible for the bursts. But it's not just the location that's intriguing. The bursts from fast radio burst 121102 show signs of traveling through an incredibly strong magnetic field. This suggests the source might be near a supermassive black hole or inside a dense cluster of young stars. Both environments would be rich in magnetic fields and high-energy particles, which could help power the bursts. Scientists have also noticed something else unusual about fast radio burst 121102. The bursts seem to come in clusters. There might be several bursts in quick succession, followed by a long period of silence. This pattern suggests the source might be something that spins or orbits in a way that causes the bursts to be visible only at certain times. If the source is a magnetar or a neutron star, it could be rotating or wobbling in such a way that its bursts are only visible from Earth when it points in our direction. Since the discovery of fast radio burst 121102, astronomers have found more than 100 other fast radio bursts. Most of these are one-time events, but a few are repeaters. Each new discovery adds more data to the puzzle, but it also raises new questions. Why do some fast radio bursts repeat while others do not? Are they all caused by the same type of event, or are there different kinds of fast radio bursts with different origins? To answer these questions, scientists are using some of the most advanced telescopes in the world. Radio observatories like the Very Large Array in New Mexico and the Parkes Observatory in Australia are constantly scanning the skies for new bursts. When they detect one, they try to pinpoint its location and study its properties. They look at things like how long the burst lasts, how much energy it releases, and how its signal is affected by the magnetic fields and particles it passes through on its way to Earth. By comparing the properties of different fast radio bursts, scientists hope to find patterns that could reveal their origins. For example, if bursts from one region of space tend to have similar properties, it might mean they come from the same type of source. On the other hand, if bursts from different regions have very different properties, it might suggest there are multiple types of sources producing them. While they puzzled over bursts, a bigger journey awaited, into the vast space beyond. Earth, that little round dot we all live on, floats around in a massive sea of space. Every person you have ever heard about or known calls this place home. It is where our story kicks off. But when you pull back, leaving behind the comfy bubble of our atmosphere and cruising past the moon and the sun, you realize that our universe is way, way bigger than you might think. The moon is the first big checkpoint on this space road trip. Sitting at about 384,000 kilometers away, that is no quick drive. If you hopped in a car and went 100 kilometers an hour, you would be staring out the window for more than 160 days before you finally got there. And from that far out, Earth looks like a tiny ball of blue and green, just hanging out in the dark. Kind of puts things in perspective, does it not? Next up is the sun. Now, this is not your average neighborhood star. It is 150 million kilometers away, a distance scientists like to call one astronomical unit. Light, zooming at an incredible 300,000 kilometers per second, still takes over 8 minutes to get from the sun to us. If you hopped on a commercial plane flying at 900 kilometers an hour, you would be stuck on board for 19 years. That is a wild thought. This bright giant keeps our little world warm and alive, even from that crazy distance. Let us keep going. Mars, the red planet next door, shows up next. When it is close to Earth, it is around 54 million kilometers away. But when it swings out to the far side of its orbit, that gap stretches to over 400 million kilometers. Trying to reach Mars in a regular plane, that is a 50-year journey. Space is not just empty nothingness. It is a whole lot of nothing spread over vast distances. Our space probes and rovers, like those cute little robots on Mars, take on tough trips filled with constantly shifting distances and tricky orbits. Heading further out, Neptune waits at the edge of our solar family. Sitting a staggering 4.5 billion kilometers from Earth, this icy gas giant marks the last stop before things get really wild. Even light, which does not mess around, needs over 4 hours to make it from the Sun to Neptune. When you think about it, our solar system feels less like a cozy neighborhood and more like a vast, spread-out city where every house is light years apart. Now, there is something cool about Voyager 1. Launched back in 1977, it has been speeding through space for over 40 years and has racked up a jaw-dropping 22 billion kilometers. That is farther than anything humans have ever made. In 1990, it snapped a famous picture of Earth from 6 billion kilometers away. The result? A pale blue dot, barely visible in the black void. Kind of a reality check about how tiny and fragile we really are. At the solar system's outskirts, there is something called the Oort cloud. This is not a place you can see, but scientists believe it is a huge bubble of icy bits and bobs, stretching out up to 100,000 astronomical units from the Sun. To put that into perspective, that is nearly 2 light years. It is where our Sun's influence ends, and the big unknown of interstellar space begins. Once you break free from our solar system's grip, the next major stop is Alpha Centauri, the closest star system to us. It is over 41 trillion kilometers away. That is about 276,000 times the distance between Earth and the Sun. Even Voyager, if it kept going, would take more than 70,000 years to get there. These numbers really start to show how unimaginably huge space is. Let us zoom out more. The Milky Way, our galaxy, stretches a mind-blowing 100,000 light-years across. That is a span filled with hundreds of billions of stars, each possibly hosting their own planets. Somewhere in there is us, inside a tiny bubble about 100 light-years wide, where our radio and television signals have managed to reach. Outside that bubble, nothing from us has been heard. To most of the galaxy, we might as well not exist. Beyond our Milky Way lies an even bigger realm, intergalactic space. Here, galaxies float around like distant islands in a cosmic ocean. Our galaxy hangs out in a local group of over 50 other galaxies spread across 10 million light-years. That is a lot of empty space between each island of stars. Light would need 10 million years to travel from one side of this group to the other. Talk about long distance. If you thought that was huge, wait for this. Our local group is just a tiny part of the Virgo supercluster, a massive collection of galaxy clusters that stretches over 100 million light-years. Thousands of galaxies, each filled with stars and planets, all pulled together by gravity into this gigantic structure. But that is not all. The Virgo supercluster is part of something even larger called the Laniakea supercluster. This megastructure spans over 500 million light-years and holds the mass of 100 million billion suns. At its heart is a mysterious area known as the Great Attractor, pulling galaxies toward it with a force we can barely understand. Imagine that. Entire clusters of galaxies, each already unimaginably huge, being yanked around by an even greater force. Beyond all of this, we hit the observable universe's limit, a sphere about 93 billion light-years wide. But here is the kicker. The universe is only about 13.5 billion years old. How does that add up? Cosmic expansion is the answer. Since the Big Bang, space itself has been stretching out, pushing everything farther apart. And beyond what we can see, who knows? Some parts of space are moving away from us faster than light, meaning we will never see them. That leaves us with a universe whose true size might be infinite, a humbling reminder of how much we still do not know. In this vast cosmic landscape, our home, Earth, feels smaller than ever. Yet here we are, exploring and trying to understand it all. And with every new discovery, the universe seems to grow even bigger. Continuing the exploration beyond the Laniakea supercluster, the structures become even more vast and mind-bending. Galaxies group together into filament-like shapes that stretch across hundreds of millions of light-years. These are the largest known structures in the universe, called cosmic filaments. Between these filaments are enormous voids, regions where there is almost no matter at all. It is as though the universe itself has formed a giant, three-dimensional web. One of the most famous cosmic filaments is the Sloan Great Wall, which stretches over 1.4 billion light-years across. This colossal structure contains thousands upon thousands of galaxies bound together by gravity. Scientists have also discovered even larger formations, such as the Hercules Corona Borealis Great Wall, estimated to span over 10 billion light-years. These gigantic walls of galaxies challenge our understanding of how the universe is organized on the largest scales. As we move outward, it becomes clear that the observable universe, while vast, might only be a fraction of the entire cosmos. Current theories suggest that beyond the observable limit, there could be infinitely more galaxies and matter, or perhaps even other universes entirely. This concept is known as the multiverse theory, where our universe is just one of countless others, each with its own laws of physics and constants. Within our observable universe, scientists use a measurement called the cosmic microwave background radiation to study the early moments after the Big Bang. This faint glow, which fills the entire sky, provides a snapshot of the universe when it was only about 380,000 years old. By analyzing this radiation, astronomers have learned about the composition and age of the universe, as well as how it has evolved over billions of years. Another fascinating aspect of the universe is dark matter and dark energy. Together, these mysterious components make up about 95% of the total mass and energy of the universe. Dark matter, which does not emit or absorb light, holds galaxies together through its gravitational pull. Dark energy, on the other hand, is driving the accelerated expansion of the universe. Despite their importance, scientists still do not fully understand what dark matter and dark energy are, making them some of the biggest mysteries in modern cosmology. On smaller scales, individual galaxies contain vast numbers of stars, planets, and other celestial objects. Our own Milky Way galaxy is home to an estimated 200 billion stars. Some of these stars have planetary systems similar to our own, and many of these exoplanets lie within the so-called habitable zone, where conditions might be right for liquid water and possibly life. The search for extraterrestrial life is a major focus of modern astronomy. Scientists are constantly discovering new exoplanets using telescopes and space probes, hoping to find worlds that could potentially host life. In recent years, several Earth-like planets have been found orbiting stars within our galactic neighborhood. These discoveries raise the exciting possibility that we might not be alone in the universe. Stars themselves come in a wide variety of types, from small, cool red dwarfs to massive hot blue giants. Over their lifetimes, stars undergo a series of changes, eventually ending their lives in spectacular events, such as supernovae or gamma-ray bursts. These explosions scatter elements like carbon and oxygen into space, providing the building blocks for future generations of stars and planets. Black holes are another fascinating feature of the universe. These regions of space have such strong gravitational fields that nothing, not even light, can escape them. Supermassive black holes, millions to billions of times the mass of the Sun, reside at the centers of most large galaxies, including our own Milky Way. These cosmic giants play a crucial role in the formation and evolution of galaxies. The study of gravitational waves has opened up a new way of observing the universe. These ripples in space-time, first predicted by Albert Einstein over 100 years ago, are caused by massive objects like merging black holes or neutron stars. In 2015, scientists detected gravitational waves for the first time, providing a new tool for exploring some of the most extreme environments in the universe. What if black holes are more than just cosmic phenomena? Could they be gateways to other universes? Share your thoughts below, hit like, and subscribe for more intriguing explorations.